CEO and design manager of designs, but Lunar Lake also. And so this is a Q&A. And so I'm going to be the moderator. I'll ask any business questions, but for all your technical questions, these two will be your men. Who wants to start? Oh, yes, sir.
Yeah. So my name is Kazuki from Japan. So my question is also your basic philosophy to implement Lunar Lake. So I think also your people is IPC and also single thread performance going up, and also E-core is also going up, but the power consumption is going down. So could you give me a more basic philosophy? So what kind of your magic? So you mean performance up and but performance power consumption down.
Why don't you talk about the architecture strategy, and then we'll get specific on it.
Yeah, so some of this I actually mentioned in the keynote. The architecture strategy has been to focus on instructions per cycle improvements. This is microarchitecture improvements. This is a, let's say, you can typically pick when doing your CPU design how much time you want to spend doing microarchitecture, which has a lot of interesting challenges because you're really looking at different pipelines and hash sizes and structures like this. Or you go spend your time doing all timing closure, and if you have very high frequency as your model, then it tends to take a lot more time to do timing closure. So we've been shifting our time more toward the microarchitecture piece because that's where you can get a lot more power efficiency. This was one of our first major steps for Lion Cove, which is our CPU here, SkyMine on the E-core. Every generation after, the same thing. Go after IPC, IPC, IPC. So this is just a standard way of doing this, to be honest with you. We just have, now we put a lot more attention to it.
Yeah. And also, when we look at what we want to achieve, we said, okay, we want to give 80% of the overall power to the core. And by doing some stuff like improving the interconnect power consumption, the ability to put the E-cores off the fabric of the core, it's saving a lot of power. So most of the tasks will run on the E-core, and if you need performance demanding, you will run on the P-core. And there are also the system case. So overall, we did several things in architecture that will allocate more power to the core and less to the SoC. And the second thing is in the core itself, like the hyper-threading, remove some of the logic for the hyper-threading, focus on lightning thread and single thread, and save power. So it's like power all over. And the last, which is also contributed, we wanted to have, usually we build the architecture that can scale up for the desktop or for the mobile. And in Lunar, like we said, let's put more effort on the design. Don't do it parametric superset. And just eliminate the logic when it's not needed. If you have 8 cores, if you have 4 cores, you don't need the 8 core logic. So this is what we did. So it's more effort, but better optimization.
And from a business standpoint, in the low power designs, in the low power workloads, the E-core outperforms the P-core. And so you have a really, really capable low power island, but then as you scale to the higher TDPs, then it's exactly how we have the headroom of the P-core. That's the benefit to the products. Next question.
Hi, I'm just kind of curious. Intel has historically been known for tuning its architectures very well for its process node, and because it's its own process node, it's kind of an advantage. I noticed that you guys are saying that the new architecture is designed and it's 99% of it can just run on any process node. So do you guys lose any of that optimization in that type of an approach? I mean, this seems a little bit different than what we've heard from you in the past.
Okay, so I will answer that. So the big challenge that we have is the high-speed design, the cores basically. And we have a lot of customization to tune to reach up to high frequencies. But we figure out that the tools today, the structural design tools, they are capable to reach high frequency. It is requiring more work to do. We did these changes in Lunar Lake, in the P-core, and it was challenging to do it in the first time. Next generation will be much easier. We see the benefit also. It's even more efficient from power perspective. So it was true, but it's no longer valid. Okay, we can use the tools today, do great stuff, and reach high-speed design also with the standard tools.
And then as a follow-up to that, Intel's also been known for kind of using its own software design tools. Everything is internal, kind of customized. Is that kind of changing? Are you guys moving more to using kind of industry standard tools, stuff we would expect from like Synopsys or Cadence?
Yes, definitely. Mainly for the high-speed design, because we really tailor the TFM, the tool flow methodology for cores for high-speed design. It was proprietary for Intel, and now we are moving to standard design. So we did it already, the shift in Lunar Lake. We are going to do it even more in the next generation.
Thank you.
Thank you. Next question. Yes, in the back here. I'll come up to you next. Yeah. Just raise your hand for the mic. Yeah, thank you.
Hello.
Hello.
I have a question. It's about Lunar Lake design about memory. It's as we know, it's a LPDDR5. The question I want to ask: it will be the trend for whole serial in the future, or just maybe for the 28 watt or 48 watt only, or will go for? Because why I ask this question, because based on the supply chain idea, suddenly if sensor micro supply tight, it will be impact your supply. So that's why I wonder, is it will be new trend, or just we will focus on mainstream for 15 watt, 28 watt with SoC only, or this idea will be try to design apply for the 55 watt in the future.
Yeah, so Lunar Lake, and Jerome will talk more about some of the decision making for where we decide to optimize the design, but it's a memory on package solution, as you've seen from the die photos. Follow on to that, Michelle mentioned in her keynote a product called Panther Lake. I don't want to tell you too much about it, but it has a lot more memory flexibility, different memory flexibility options built in, so we can scale it across, whether it's a typically 15 watt TDP, if we use that term, to higher. Lunar Lake, we just want to have that one major mobile optimized way to really get the architecture in good shape, and then we got to go scale it. So it's sort of a first step is get the architecture, and the second step is scale it. And the scale will include a lot more flexibility for thermal design points and memory technologies.
One of the first questions was, how to save power. So, as I said, we remove when it's not needed in Lunar Lake. So one of the things that we remove is the support of the combo file, that support DDR and LPDDR5. But it doesn't mean that we will do it or support the next generation. It's like, building the most optimized for power. But again, as Rob said, it's for Lunar Lake. It doesn't mean that we are stopping support.
It is one of our options for super optimized thin and light designs that we can always utilize. And specifically for Lunar Lake, there are multiple memory suppliers to address your concern about not having enough supply. We've been doing deep supply chain protection on that. Thank you. Next question, right here. Sir. I pointed to this guy, gentleman in front. I'll come to you next, okay?
Hi.
Thank you.
My question is also about memory, about memory interface on the Lunar Lake. So the Lunar Lake's memory interface is 16-bit 4-channel. So that means the memory bandwidth is around 68 gigabytes per second. If you utilize 8.5 giga transfer per second. So do you think this is good enough? Why didn't you make it 120-bit like Meteor Lake?
I don't think I have a good answer to that, but actually, I don't know. I think this is the requirement for Lunar Lake.
I'll take it as a product management, not Mike. As the product management person, there's like always more I wish we had,
Yeah.
right? It's like there's never enough for us in product marketing, but this seems like the exact right balance. We did deep analysis with our customers and their designs to pick this design point for the first one. So it's a choice we made, and it seems like based on design feedback, you'll be the judge when the product shipped, that it was a good design choice for us.
It's there were many trade-offs, not just that. Okay, and the trade-off again is save power, do only what is needed, not think about it something that can scale up. For the next generation, we will take the penalty of scaling up because we know that we're going to support several segments. But for Lunar Lake, we removed whatever we could.
Yeah, power efficiency isn't an instruction set choice. It's a set of design choices, both at the IP and the logic and physical level. And so that's where we put all of our energy to show that x86 will be a great performance architecture. The gentleman too. Oh, go ahead, please, Ryan.
We look at the next set of workloads that follow this. And so we grow business memory bandwidth. So there's just a look in time at what the workloads are, what your product's trying to do. As he was mentioning, the next generation product is broad scale that we have and higher memory bandwidth.
Thanks for your patience.
No worries. If we look at your chips in 2020, when the Apple M1 came, and we look at your chip right now, it looks a little bit much like an M1. You introduce like lower cores, like the E cores. Now you embed the memory. Do you plan to follow a little bit the trend and to add more horsepower in terms of GPU? Because when you look at Apple SoCs, basically between the ultra low core, it's mostly the GPU that scale up. And now you have a good architecture. Do you think you got a market to develop this kind of SoC where you limit yourself in terms of CPU, get enough, but you expand the GPU side for more heavy workloads?
Let me talk about the software aspect first, and then we'll come to the product aspect. But as we work with ISVs, and these are not just AI ISVs, they're our ISVs, the word is and. About a third of them go after CPU for performance, but also for AI. About a third, maybe even more than a third today, use the GPU for AI. And the NPU we eventually think will grow up to be a third. And we've had this discussion, like, we're learning as we go. The first place they go, typically, is the GPU. And then they start peeling workloads off that you think will be power efficient, either to the low power island or the NPU. And so from a strategy standpoint, I wouldn't say it's not an or for us, it's an and we have two low power E-cores in Core Ultra today, and they give us about a 20% performance power impact of the same performance. We just wanted more to run there. And I'll let you add architecturally if you'd like to that. Anything?
How much I will say.
Just to put it in context, I would like to have a PC which has like a very big embedded GPU, like Apple, like a MacBook Pro 16, but with x86 and a strong graphic, and you don't have that in your hand.
Well, the Lunar Lake has a pretty sizable graphics unit built into it. So we would typically, if you look at the type of segmentation where customers are buying products, you'll have some segments that it's not as high value, let's say, right? But then you start to build up and add more graphics capability. So Lunar Lake.
You're going to do that?
Yes, absolutely.
Yes. I want to. Okay, so it was a calculated decision when we do the graphics. We understand, the trade-off, but of course we want also to scale it up. It's a balance between, cost and performance, but we do want to scale it up and.
Well, yeah,
plan to do it.
I guess I'd say this is a discussion about future of chip design. So as they've made the things plug and playable, and with the Foveros technology, Rob and I can now, based on what segments require what, do a simple configuration by adding CPU P-cores, CPU E-cores. And so we have this capability And then they built the infrastructure to do
scale
more
it up.
SKUs like that. Next question. Yes, sir.
Yeah, having launched Meteor Lake, of course, and looking, having looked forward to Lunar Lake now and Panther Lake in the future, what have been some of the lessons learned from launching Meteor Lake, unlike some of your competitors who are only now showing up to the AI PC fight? Perhaps right when Microsoft has clearly delineated what is actually necessary for Copilot Plus and the like.
Our strategy with Core Ultra Meteor Lake was build a hardware footprint of 40 million units. As soon as we had confidence that we could commit to that, all the ISVs saw an opportunity to develop on our platform. And then we added to next year to 100 million units, and our pipeline continue. I don't know. I can't give you the multiplier, but we now have an ingest process on how to support any ISV. If they're a large ISV that needs engineering help, we have a process for that. If they're a longer tail new ISV, we have an onboarding form, we have a website, we have a developer kit they can buy. And so I would say the hardware footprint with growing CPU, GPU, and AI capabilities is first a great product on its own, and then as AI has been like that got the flywheel spinning, if that makes sense. And so the only lesson I would have learned is maybe started that 6 months earlier.
Right.
But you know, you can only change it when you realize you should have done something. You do it, and we did that 6 quarters ago, and now we have great adoption to that. I'll ask you on the architecture engineering side what you would add to that if you'd like.
Yeah, actually, when we decided, at least on Lunar Lake, to put a strong NPU, we were not aware to the full story of Microsoft model. Things were developing, so we definitely want to bring more AI performance, and we did the right choice eventually. But I'm not sure in Meteor Lake time frame the awareness was the same. Definitely it was not clear. Even today there are some lack of clarity, how the Copilot will leverage all these capabilities.
But I'll say what Rob has brought to the party is total platform tops, and build a great PC first that can grow its AI capability. He really brought that clarity to us within Intel, and it's really paid dividends for us based on ISV feedback.
So it's basically build and they will come, kind of.
Build what they're excited to invest in. I wouldn't say build it and they'll come. It's like they were looking for the platform to attach to, and we had a lot of attachment. Next question.
With Sapphire Rapids, Intel kind of had a problem with a lot of different steppings, and they had to do multiple respins of the chips before they were launched. And then around that time, they communicated that there were some changes being made to the design and verification methodology that you were using to kind of address that. Can you kind of give us a sense of how many steppings it took, or were there any changes that kind of alleviated those concerns?
Yeah, maybe you talk about how you achieved V0 on Lunar Lake. That's the best
I
way
can
to
talk
answer
about
this.
Lunar because I'm from the client segment and not from the server segment, the data center. But when I started to manage the project, I thought that the most important thing to do, first of course to bring a lot of goodness to the product, but meet the timeline, super important, and reduce the number of bugs from silicon. So one of the technical readiness and the feasibility studies that we did is how to get to A-step PRQ mindset. And we tackle all the vectors that related to A-step PRQ mindset. A lot of work on the validation, doing more formal, more emulation, all the stuff. But the mindset is they said you're fully featured, fully implemented, fully validated in A-step, and this step will be reactive. If you find bug. So this is a change in mindset, and I'm happy to say that we achieved, of course, we always need to improve, but we really managed to reduce the number of bugs in silicon and do it in piston.
And he delivered our QS silicon, which is the production candidate, a week early for Q3, so thank you.
Thank you.
Yeah. Next question. Yes?
Yeah. So I think.
Hold on one more.
Okay.
Thank you.
Yeah, I think Media Lake. So you have a 1, 2, 3, 4 die. So more split. So but this time so you have a 2 die only. So could you give me your philosophy why so you choose only 2 die so in this gen?
It's going back again to the power efficient.
Mhm.
So we understand, when we did the evaluation that graphics, when you do disaggregation of graphics, you have some penalty on the die-to-die power. And also, but it's still okay if you want to scale it to several segments. In Lunar Lake, we didn't plan to several segments, so we said, okay, let's put it inside the die. On the leading process, and the second thing is that from the I/O perspective, the I/O die, the tile, we didn't need this scalability of number of I/O ports. So from the same reason, we didn't have this I/O. So we ended up with the 2 tiles. While we moved most of the content also to the leading node to gain more power performance.
And I think the Media Lake it's developed by Hillsborough, so you mean R&D center. So how about the Lunar Lake? It's based on Haifa so or something.
Correct.
Okay. Thank you so much.
Yeah, thank you. Next question. Yes, ma'am, right there in the middle.
Hi, this is Claire from India. So I have 2 questions. The first one is a little bit a niche question. The question is about the shared DSP. I think it's programmable and it has a very long history. You said this is the 6th generation, right? In the NPU platform.
One more, shared?
Shade.
Shade, okay, yeah. Shaved DSP.
Yeah, shaved DSP.
Shaved DSP, got it,
Yes,
yeah.
yes, that's right. So I'm just curious. I'm still learning the DSP versus FPGA, but when it comes to programmability, I think everyone thinking of FPGA or embedded FPGA. So I'm just wondering what's your consideration that you adopt the DSP rather than FPGA or embedded FPGA? So that's the first question.
Did you attend the breakout session on the NPU? The AI accelerator?
Yesterday.
Yeah,
I was there.
Darren Cruz covered what we did for the vector, the vector processing, the shaved DSP, and the program. He covered it in that session.
Oh, okay. Then the second question is more sensitive. It's geopolitics. So is that COMPUTEL is based on the TSMC N3B. So just wondering, are you planning, adding more foundry partners, in case as a backup plan in case the worst thing happens? So just curious about your thinking. So I know there's no right or wrong.
I won't take the geopolitical question, but we are always able to choose the best process node to build the best product. And we're not disclosing what those products are, but it's a key part of our strategy, and we've had a long-standing relationship with external foundries, both in our communications business and CPU business, and that will continue. Next question. Let's go first here, and then we'll go to the back one, okay? Yes.
Hi. So in the GPU architecture session, I have seen the pseudo diagram of the GPU design, and I've noticed that the size of the NPU is enlarged extensively compared to the last generation. And based on the technical details, we have seen that the acceleration units have been maybe enlarged to 3 times. So I'm a developer, and from a developer perspective, I have seen that most of the computation is still on GPU side. So what's the expectation here? What are the works that are left to do? Are there a lot of work that is required to make this shift?
to make the,
The shift from like GPU computation to NPU computation, as most of the computation currently are based on GPU, right?
yeah, we believe both are important, for sure. If you look at the number of workloads we'd like to have, like running in low power domains, the NPU is, I think we says 48,
Up to 48.
up to 48, use the right term, up to 48 PTOPs.
Thank you.
So we will continue to invest in the NPU over the roadmap and horizon, but we want to do it very carefully because you notice it's big. So as we try to make that bigger and bigger, it starts to consume more silicon area, which can add more power and more cost if we're not careful. So we're very, very carefully moving that forward, upgrading it. But we're still continuing GPU as well. There's no reason to pick one or the other except for where you want to land the workloads. For the developers, what kind of workloads do you want to do? Do you want to do low power workloads that are running all the time in the background? You probably want to put that on an NPU. If you want to operate, it's easy to program on the GPU, right?
So we get this question also, even inside the team sometimes. It's a good question. And it's like Rob said, there are different things running on a different, for GPU we are running, more power, high demanding performance, and it consume more power, and the NPU is for more power optimized. We could create some common logic between them, say, okay, let's do it more optimized and call it one GPU together. Maybe it was something that will happen, but it's actually two separate functions. You can just put a square and call it GPU, or separate it. So even the competition, they're just not separating them. If you look at Apple, they will have some NPU, but it will be smaller because most of the work will be done in the GPU.
So for Gen AI, you're a developer, so you may know this, but like Gen AI is a really hot topic for creators. Even when you do Gen AI, when you're figuring out what to generate, that's very much a CPU task to get the first revision down to, say, a drawing you might want to draw. Then you go to the GPU to refine that, so you like really quickly get to the image you want, and then you typically would render it through the NPU. This is general. Applications may vary, but we're not seeing a wholesale one or the other. It's a blended approach, and our architecture works quite well with that. Thank you. Question 2 rows behind, or 3 rows behind, I can't see the count.
Sorry. I was wondering, had the high bandwidth memory solution being considered? We are using 3D Foveros advanced packaging to being integrated to, say, Lunar Lake to expand the AI experience initially.
Rob, please.
Yeah, we're certainly seeing that in data centers, especially graphics class AI training. It's very expensive.
Okay, got it.
Yeah, okay.
Thank you.
For your
But
question.
your question's it's in the right mind of where do we need to go over time to get more memory bandwidth? It's similar
Yes,
to one of the
yes.
questions asked earlier. So
Yeah.
as we're staging through and trying to responsibly bring the next level of AI and the next level of AI, the memory is a part of that entire architectural principle.
Yeah.
Memory bandwidth has to go up. So the question we're still looking at is, at what point is the traditional way of running LPDDR or LPDDR6 emerges eventually? Is it enough?
Okay.
If it's not enough, what else? And we're definitely deeply looking at that.
Okay. Thanks a lot.
Thank
But
you.
it can't be like super high cost, then the PC is not the PC, right? That's
Yeah.
become the data center.
Yep.
Okay, a new questioner right up front. One moment, please.
I understand that the computer tile of Lunar Lake was made by TSMC. And could you specify of which node was used to manufacture the computer tile of Lunar Lake? And I think that you can change you can change which foundry do you which foundry to use, and when did you decide to use external foundry in the initial stage or finalizing stage?
Initial. Surprisingly, I know, but you know, I know where you go. No, but in Lunar Lake, again, in Lunar Lake, we said we want the best performance, best power performance. And when we looked at the overall numbers and say, you know, time to market, performance, power, what do we have available today on both sides, in external and internal process foundry, then we took the decision. We didn't react to that, otherwise we went mid-schedule, right? Because there is a penalty to late decisions. So it was in the first day.
Made sense for this particular instantiation.
Yeah.
For the CPU, Lion Cove CPU itself, for example, it's on, we actually have it in several process nodes, actually. Or distributed between TSMC and Intel. We're not going to announce anything on this, but as we talked about the core and the way the architecture of the core was evolving, it's able to be put into multiple nodes at the same time. But for this product, what we're trying to accomplish this product, it was the right decision for that product.
One more question.
Go ahead. You have the mic.
SkyMulti core IP and XE2 GPU IP is so impressive, and could you provide these IPs to external customer or Intel Foundry and let them make some customized x86 CPU?
No, we have no plan on licensing like that to TSMC for this core. Why don't you, I'm going to work my way back to these three, so hand the mic to you here, and then I'll just go right back for efficiency. Is that okay?
Quick question. The
Yes,
base
thread
type.
director.
What's that?
Yes, thread director.
You're the thread director now.
I'm a pretty slow thread director, sorry.
Quick question for you. The base type process node name is 1227.1, but what does the number mean?
Yeah, revision, you know, sometimes we are doing incremental changes for the
What's the geometry?
beam
He's asking?
capacity.
He might be asking the geometry.
The die size?
Like the geometry of the node.
yeah.
It's not 20A, is it Intel 3, Intel 4, is it?
Oh, it's an older process, I believe it's 22.
22.
Yeah, it's just, it's a base die for.
It's, you know, there's no logic on the passive base die. It's mainly to hook the
Metal
dies,
detector.
and you know, if you can use it, by the way, to active base die, and then you need to invest more if you want to put some kind of an S on, a big S on, but this is not the case anymore.
Yeah. Thank you. Do you have the mic?
I don't let Paul was going to say.
The thread director just passed an available question. We'll go back to you.
I'm pretty sure you remember Lakefield, which was
Yes.
very interesting. That was your first implementation of formulas into a mass market product. And I'm kind of surprised. And do you think you're going to keep this kind of product when you put the RAM on top of the layer of the chip to reduce the footprint? Because at the time when we had a look at the motherboards, they were quite compact. We see your competitor developing like APUs, like to run gaming console and stuff. And with the IP you get good P cores, good E cores, good graphics, and you have the know-how on to stack everything, like the RAM on top of the chip. Could you do that? Are you still considering this, or there are still thermal problems with that?
Yeah, I would answer thermal.
Yeah.
Thermal constraints immediately. But I don't know if you looked at that when you were doing the Lunar Lake.
No, we didn't.
You know,
It wasn't the option.
the PC TAM is 275 million units going to 300 million units. A Foveros type capability gives us a lot of choice to do product configurations very efficiently for design. And so we continue to see that capability improving and the cost coming down as we scale volume. So, and from a thermal standpoint, it's a much better solution. So I would say tiles are a strategy, and interconnecting them with Foveros is our plan, right?
Yeah, it's just where the memory resides.
Yeah.
You know, we have you've got between the P cores, the graphics, especially as we're getting bigger products and other versions as we scale out the architecture. Yeah, I wouldn't want to put the memory there also.
Okay. Thank you for your patience.
Okay, so I have a few questions. With Foveros, with Lunar Lake, are you still using a 36 micron bump pitch as you did with Meteor Lake?
I know the answer. I don't know if it's okay to answer.
Yeah, we've talked about that.
Okay, so 20. No, it's small.
It's what, I'm sorry?
25.
25?
Yeah.
Okay. And since that's a different bump pitch, and this seems to be kind of I would say a simpler design than Meteor Lake, do you guys foresee any packaging constraints? Because I know that Gelsinger has said recently that some packaging constraints were kind of limiting how much they could sell from Meteor Lake.
No, during the beginning of the project, we had some challenges with the 25, but we resolved it fast, and so we don't see any issues with the packaging constraint.
Yeah, that was a tactical wafer level assembly issue with Meteor Lake that we've been ramping with Meteor Lake, and we've been resolving it and meeting demand. The good news is demand's strong for Meteor Lake,
Yeah.
and so we're just ramping a new capability of wafer level assembly, which will continue to be one of our key process.
Well, one of the challenges is, to show the time for wafer level assembly. This is the thing that we are trying to improve.
Yeah. Another question, or was that it?
That's it.
Okay, thank you. One moment. Other questions near the back? Since okay, here we go. Let's.
Well, we look back to the 12th gen desktop CPU like Lunar Lake and the Raptor Lake refresh. We see that consume more and more power to get a little clock increase. However, on the laptop side, when we see the Raptor Lake and the Core Ultra 1 series and 2 series, each generation just get a little performance increase, but a great improvement in power efficiency. So can you explain what is the two kind of philosophy for of course for different devices, but then what will happen to the next generation desktop CPU?
Okay, so we're not going to be talking in detail about Arrow Lake today. That'll be the next one. So we're not prepared to go into detail on Arrow Lake unless you want to give some general architecture views on that.
I'd probably say too much.
Yeah, then let's. No, so we have to know we have detailed plans. We have a lot of data and information, but we really are here to talk about Lunar Lake at this technology tour, and we'll have Arrow Lake discussions before that. For that product, that product will come next, right after Lunar Lake. So we have answers for you, but I don't want them to wing it because we haven't prepared for that. Okay? Thank you. Next one, was there another one back here, or did I come up here then? We got about 5 minutes left, so 2 or 3 more questions if you have them. Right here. Thank you.
Just one more quick question. I remember that Pat demoed Gen AI using Lunar Lake locking sample on last September in the Intel Innovation event. Was the product demoed at the time also powered by CPU types made by TSMC?
Pat did not demo Lunar Lake. We have not been demoing Lunar Lake products yet. So you would have seen Meteor Lake if it was last year at Vision.
No.
No.
No, it's right.
Innovation.
It's right.
Innovation.
He showed the device and it said.
Oh, he showed a device.
No,
Okay.
it was on
Oh,
on stage, and he created a Gen AI.
What was the
There was a
question?
Gen
Oh, okay, I
AI,
wasn't
there
at
was
that event, I'm sorry.
I'd like to
innovation,
know what
etc.
that was at TSMC.
Oh,
Yeah.
the product's built
Yeah, this is-
with TSMC time.
You're asking the same question
Yeah,
in different language.
yeah.
Yes, it was good.
Yes, ma'am. And then we'll come.
Just the product strategy. I'm not sure if it is okay to ask.
Oh, anything's okay to ask, but some things we may not answer today, that's all. Yeah, that's.
The Lunar Lake platform, just curious, of course it's for IPC, so I think we spend more efforts for notebook or laptop. What about desktop?
Oh, this was the question that was just asked up here on what about
sorry, I
desktop?
missed that.
And that's the Arrow Lake platform, which is our next product that is right after
So you
Lunar
mean
Lake.
for Lunar Lake is not
Lunar
for-
Lake is, it is a
Laptop.
mobile product designed targeted for mobile. Thank you.
Thank you.
Another one, you're gonna wear us out. Right here.
Last one, I promise.
I don't believe it, I don't believe it.
Good question.
Okay, so, there's been a lot, you guys are talking a lot about Foveros design, but bringing the DRAM on package is also a pretty big advance. Are you guys just using like traditional organic substrate packaging with that, or are there any special sauce that you're using to connect the two chips there?
No, the traditional.
Okay. Thank you.
Any last question?
We have one more?
Raise your
Raise it
hand.
high.
So she can't see you, thank you.
So maybe the last one will be more general and regarding the future. Do you think the direction for all the PC market is a unification in our production? Because we have now Lunar Lake, and Arrow Lake is supposed to be kind of scaled up processor. I mean, maybe I am wrong, but the thing is, we see all the usages, we see all the scenarios, and it's always about this is gonna also work here and there. And I just wonder if the way of producing chips is to unify them and just make them bigger, make them more power consumption. Is it like the ultimate way for a market, or is it just a phase?
Rob and I have the assignment to make sure we cover all the important segments of the 275 million to 300 million unit TAM. And some of those segments are very cost sensitive. Some are very battery life focused, like the Lunar Lake systems. Some are mobile creator gaming, and then we have desktop gaming and we have workstations. So I don't see a unification myself. I see reuse of capabilities at different configurations. I would like each of you to answer that since it's our last question.
Go ahead.
Go ahead.
Okay.
What do you think?
Yeah, basically, we are trying to improve and have nodes in the design before even we do the structural design, and not to pay the penalty for superset design. Okay, so we look at that, and also when we define the cut line for a family, we want to make sure that we can have as much as we can segments that we can support, but still to have a nice mix and match. So we are looking at all of this trade-off, but in mind we are thinking, not to pay the penalty of like a desktop power in the mobile segment. This is what leading us, because we are trying to fight for every milliwatt.
Rob? And conclusion, maybe we close too.
Okay, so really each of these segments he mentioned is that there's different usages. So let's say in the desktop workstation, right above desktop, a high-end desktop workstation, you might have currently a large number of CPUs, multi-threads, and then also some GPUs, let's say they're external. That's a totally different design point, optimization point than mobile workstation, or let's say a typical 15-watt consumer mobile. So we think it's important to bring the right level of compute for the right experiences that people are looking for in the PC. It's something we really enjoy doing, is having that broad level of experience diversification for all of our customers. This will continue. We think it's still the right strategy for sure. The nature of your question, I mean, to some degree, sorry, I can't see. If we just went after one thing or two things, we could optimize for those things. That's true. We just did it at Lunar Lake.